I do apologize for not being there. However, we must continue with the review, especially for you seniors, because your finals will begin on Tuesday and Wednesday, and we do not have class on Monday because it is a holiday. So therefore, I have made these videos, which will be available on my website as well during the weekend for those that need to go back and review. If you left the review with me, I place those reviews on the top tray. So one person, if you could go to the top tray and just go ahead and pass the reviews along to the appropriate person. Also, if you ever need to stop the video so that you can write down the notes or the steps, by all means, make sure you tell the substitute or whoever is in charge of the computer to pause it, or you're more than welcome to replay it and look at it over the weekend. So let's go ahead and start. I don't really know. I kind of stopped somewhere around the same vicinity in every period, but for starting purposes, we'll start with number 18. Number 18 says the equal size squares are cut from the corners of a rectangular piece of cardboard. Flaps are folded up and taped. If original is 13 inches by 10 inches, what is the max volume? So let's go ahead and start with number 18. We know that volume, I think we even started with this one. Let's see. Volume of a rectangle or a box is length times width times height. And we said that the length is 13 inches. However, I've said that those flaps each will have a dimension of x, so 13 minus 2x. And the width is 10 minus 2x. And when you fold those flaps upwards, the height will simply be x. So let's go ahead and place it into one line. So we have volume equals 13 minus 2x times 10 minus 2x times x. So now we need to go ahead and actually type this equation into your y equals. And I do have a y equals calculator right here. So it may look kind of close to yours. It should. So what we'll do is we'll click on y equals. Let's see. On. Y equals. Okay, mine is acting up, so let me reopen it again. Okay, so y, and we have 13 minus 2x times 10 minus 2x, and then times x. Okay, so after that you want to press graph, and you should get something like this. Although you don't necessarily see the entire picture, you get an idea. Now what you need to do is you need to press second and the trace button. And since the question says what is the maximum volume, that's exactly what we're looking for, maximum volume. So you need to scroll down to where it says 4 and press enter. At that point, you have a cursor. It's asking for the left bound, and that's perfectly fine. The cursor, I want that cursor to be there at the origin. That's a perfectly good spot for it. So you're going to press enter. Then it's asking for the right bound. So you're going to move this right cursor, and what the cursor does, it goes along your curve even though you don't see it. So it's going to take a little bit of time. Just keep on scrolling to the right, and eventually you'll see it. Let's see. It's going to take a bit because it is a big curve. Okay, there we go. It starts coming up, and it's going to start going down and then back up again. So right there is about a good spot for you to stop. So you're going to press enter, and then it's going to ask, am I ready to guess? And you're going to press enter also. And your y value, which is right here, It says 108.4. That's your answer. Your Y value will be the maximum volume that the box can handle. So in this case, for this problem, it'll be 108.4 inches cubed because we're talking about volume. Okay? Now let's go ahead and go to number 19. Number 19 says the loudness in decibels of a sound is L of X. So actually, let me pop it open for you. Right here. The loudness in decibels of a sound is L of X equals 10 log of X over 10 to the negative 12, where X is watts per square meter. If L equals 70, find X. So at this point, I'm going to go ahead and go to a clear document so we can actually work it together. And I'm going to actually type in the given equation. It says L of X is equal to 10 log of X over 10 to the negative 12. And it's in parentheses. It doesn't have to be, but I guess we can put it in parentheses since that's how it is in your review. Okay, so at this point, this is what we have. And it also says that L is equal to 50. No, 70, I'm sorry. L is equal to 70. So that means I can replace this part right here with 70. So we'll go ahead and do that and replace it with 70. Okay, so now this is what I have. Let me make it a little bit smaller. So I have 70 equals 10 log of all of this stuff right here. Now we need to isolate the log. This is a log equation, by the way. So we need to isolate the log part, and that means we need to get rid of this 10. Well, what is this 10 doing with this log? It's being multiplied. So for me to get rid of this 10, I have to divide both sides by 10. And when I divide both sides by 10, I get 70 over 10 on this part, which gives me 7 equals log of all of that stuff right here. So that's what we'll do. Now, I can't log both sides because on the right hand side I will have a log of a log. So if you remember with equations, if I can't log, then I'm going to raise to the power. And I'm going to raise to the power with respect to whatever base this log has. Well, remember what I said. If it doesn't have a base given to you, then you automatically assume it's the base of 10. So that's exactly what we're going to do. We're going to use the base of 10 and raise it to the 7th power equals, and then we'll use the base of 10 and raise everything that's on the right hand side. Okay, at this point, we still have 10 to the 7th on the left hand side, but on the right hand side, remember what happens to these two right here? It's as if they cancel and it only leaves you with x over 10 to the negative 12. So at this point, I have 10 to the 7th equals that stuff right there. This time I'm going to go ahead and take out the parentheses since nothing else is in it. If I can, probably not. Okay, I can't. So we'll just leave it like that. All right, if I currently this 10 to the negative 12 here at the bottom is negative 12. If I want to move this entire thing to the top, it becomes 10 to the what? Right, it becomes 10 to the positive 12. So now I have 10 to the 7th. So let's go ahead and paste it here. 10 to the 7th equals 10 to the 12th And don't forget about your x. Okay, so now the only thing left to do is to divide both sides by 10 to the 12th. So now when you divide both sides by 10 to the 12th, you actually have 10 to the 7th over 10 to the 12th equals x. And then what do we do with like bases and their exponents? We subtract. So what's 7 minus 12? Negative what? Negative 5. So our answer is 10 to the negative 5 equals x. And that's also equal to what? If I want to make this negative 5 as a positive exponent, I can simply move it to the bottom. So it's also the same thing as 1 over 10 to the 5th power. Perfect. So that's number 19. Okay, because I'm running out of time on this recording, I'm going to do 25 because it seems like it's going to be a quick one. So let's go ahead and start with 25. So while you flip to that, I'm going to go ahead and look at it right quick. It says set up the equation for the height of the tree. Now you've seen an example like this on your tests before, only on your tests it's probably a lamp post. So either way, let's just analyze what we have. I'm going to zoom into it. We have our angle theta. This shape is a right triangle. With respect to theta, this tree or the height of the tree is opposite, adjacent, or hypotenuse. It's opposite, and then this distance right here at the bottom is opposite, adjacent, or hypotenuse. It's adjacent, so which trig function involves opposite and adjacent? Well, that means that it's tangent, SOHCAHTOA. TOA. Sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So at this point, we have tangent of theta equals, and let's call the height of the tree x over, and the adjacent side was 7. Well, how do you solve for x? You want to get rid of this division by 7. So the way you get rid of that is by you multiply by 7. So in the end, you have 7 tangent of theta is equal to x. And that would be our setup equation. Okay, any other questions so far? Okay, great. So let me go ahead and stop this recording and move on to the next one.